All right, welcome to Earth Science, everybody. So I'm going to talk about the lab you're going to start, which deals with the lag in temperatures between the time when we get the most sunlight and when is it actually hottest. You're going to plot out both of those. Yay, more graphing, just what you wanted. But first, let's go back to the notes we just did. Depending on your single double schedule, maybe today, maybe yesterday. And think about the idea that the sun heats up and then that heats up the atmosphere. What this results in is that there's not an instantaneous moment where on the day where we get our peak sunlight, which if you remember your seasons, your 4 special days, you should know that. It's the summer solstice. That's not the hottest time of the year. Think about that. I mean, when is it really hottest? I'm telling you, I mean, we all know mathematically that the sun is at its peak and the summer solstice, which is around regent season, June 21st. When is it actually hottest here in Alaska, New York? Usually not until like August is when it gets really hot, right? So the deal with that is that there's a bit of a lag. This whole thing takes a minute to happen, right? Or a couple months. It's the same thing happens throughout the course of a day. I don't have a good lab for this, although I should come up with one. Where high noon, when the sun's at its highest peak, is generally not the hottest time of the day. All things being equal, if there's not a cold front or a warm front coming through, if it's a pretty standard day, the warmest time of day tends to be like 2ish in the afternoon. There's a lag, and it's because of the effect of the idea with the sun heating the earth radiating off that energy. It's not an instantaneous thing, right? So that's really the point of that's the thesis of this lab that you're going to do. All you're going to do is demonstrate that with some graphing. Now, here's a terrifying amount of numbers. Let me tell you what all this is, and don't panic. You don't have to do it all. Month 1, 2, 3 is in January, February, March. Day, right? Insolation, how much sunlight happened. Now, what I did for that, I found this data from a website, and I did this all, you guys don't have to actually do this part. It's all on here for you. A website that deals with the installation of solar panels for people. People that want to put in solar panels, they see like what amount of energy, that's what a kilowatt hour is, hits a square meter in a day. That's what that crazy unit is. So it's just a way of really saying how much sunlight is hitting a box that's meter by a meter, right? And then temp, I just ran about 10 years worth of data, did an average in Excel, and then dumped it into this, right? So here's every single day of the year, how much sunlight happens, and then what the temperature is. Now, yes, some of these are blank because even though I think I did maybe 6 years worth of data on this because it was pretty tedious. Um, some days there's not data. I don't know if it's because it was cloudy on those days or if the equipment was down or what might be, right? I think they have some sort of stipulation for how they want the atmosphere to look like on a day where they actually record a data point. And if it's not right, then they just chuck it, right? So I did like 7 years of the data, but that still left us with some blanks. Still, the trends are pretty good. This lab works reasonably well. Okay. So there it is for the whole entire year. These questions you'll actually do at the end. So wait until the end to do that. Here is a bit of reading to help with why we have a lag, or when you get to this question right here, like, why does this happen? Go back to the beginning of this video and talk about it. So you're going to be plotting on this graph. Now, what I did, because I wanted to give you the axes, was rather than trying to talk everybody through doing that, I just filled it out and scanned it this morning. So let's rotate this. Counterclockwise. All right, so here's what this is going to be. The only slightly new thing here is that you're going to have two separate axes. You're going to do a graph for insulation using these numbers throughout the course of the year. And then over here, you'll have a graph for temperature throughout the course of the year using temperatures. So you'll end up having two lines like that. There's a rough idea of what it's going to look like. In Cami, use two different colors. I had people use two different like symbols when we did it before. So take the insulation number, put it on here. Now, to get rid of most of the data, just do these days. So therefore, you're only plotting about every 10 days. So do January 1st, January 10th, January 20th, January 30th, and so on. And if one of those happens to be blank, just do the best you can at coming close to it. Because, chances are at some point one of those is going to be blank without wasting too much time here. Let's say it was the fourth. You don't have to plot the fourth, but it was the fourth. You're like, oh crap, that's blank. What am I going to do? Well, it's on the third, it was 4.6. On the 10th, it was 4.5. Those are pretty darn close anyway. So just estimate it. Cut the dot right about there, and you'll be good. Okay. If you want to know like the first day, so what was on there? January 1st. Yeah, January 1st. So here's what this would look like. On January 1st, the insulation was 2.2. So I'm not in Cami here. I can't actually do it. But on January 1st, the insulation is 2.2. Put a dot in whatever color you choose for insulation there. Then the 10th, what was the insulation? On the 10th, it was also 2.2. So you go and you put a dot on the 10th on 2.2. And then just plot those as it goes in one color. I think you should do all the insulations first or all the temps first. I think you should do it separate. Don't try to do the insulation and the temp. I think that people did that last year and they just kind of got fouled up. So then later on, once you've done all those insulation ones, then come back and do the temperature ones. So on January 1st, the temperature is negative 0.3, just a tiny bit below zero. And then 10th, it's negative 1.3, a little colder. So on the first, now you got to look at this axis and come way back over here. On the first, it's was just a bit below zero. So on the first, it was like right about there. I know I'm not in Cami, I can't draw. On the 10th, it was negative 1.3. So you look and see where that is, right about there. Just keep in mind to use this axis for temperature, and you're just working that way. Other than that, it's no difference. And this axis for insulation. And again, when you're done, just build two nice curves that look like that in two different colors. Play the connected dots if you want to, or just leave them like that. And then think about the questions. It's really just like, when do we get our peak insulation? When do we get the highest temperature? When do we get our lowest insulation? When do we get our lowest temperature? And then there's a lag between them. And explain that using what I said at the beginning of this video. And you can pop this thing right out. You'll be great. All right. Thanks for sticking with me. Good luck in the lab. Oh, I gotta move my face. So long.